Okay, let's start the class. So in today's class, we are going to see about regression based problem, and we are going to solve it using our TensorFlow. Okay, by using the neural network. So basically for what and all we will go for the regression type model or classification means mostly the questions are rising with how much or how many, like what is the price or sales, like that we will go for the regression type, right? So here in our example, we are going to take an house price prediction data set. Okay, based on that we are going to find what can be the price, how much our model is able to predict, like that we are going to find. So for example, we are having three independent variable means those three variables will be converted into numerical encoding. So and then it will be passed to here. Machine learning algorithm is nothing but our neural network. Okay, so it will pass to our neural network and then it will try to predict some output, and then we will try to compare with the actual output and the predicted output, and we will find a mean error and accuracy, everything we will do, right? So that is what we are going to do. So here in this example, small example, we have only three input independent variable, right? So the shape of my input is going to be 3, and then my output is always going to be one value. So I'm going to get the price of my house, right? So the price will be in shape 1. Okay, we can do different neural networks by passing different neurons into each network, how it is predicting the value, okay, how our accuracy is changing, okay, everything we will try to see. Okay, so we have seen the neural network anatomy, right? The first layer is going to be our input layer. Okay, how many inputs we are going to pass. Here input, how we will decide based on the columns we are choosing. How many columns we are taking, all will be taken as input layer. And then the output is going to be only one. Okay, which is the price for my house. And then in between, how many neural net hidden layer you are going to create. In each hidden layer, how many neurons you are going to place. Everything will be by practice, by changing the values, you will try to find, okay, how much accuracy it is going to give. Okay. Okay, here simple example has been shown. Like we are not going to use the same code, but similar like this we are going to use. Like as we have seen, first we will create a model, right? Previous steps and all, it is going to be little bit common only. So taking the data set, splitting them, all will be going to be common. After that, we will in this place in machine learning we might have called the algorithm, machine learning algorithm, right? Here we are going to call the neural network structure. Okay, here model has been created using the sequential. So first the blue area is there, right? So that is going to be my input. Okay, here they have mentioned as dot input, but we can do the same thing by giving TensorFlow.layer.dense. So by giving the number of units, as well as if you are passing the input shape means, so that layer will be taken as our input. Okay, whereas when you come to the last tf.keras.layer.dense, one is there, right? So this is going to be my output layer. Okay, here you don't need to specify any activation uh, function. Okay, it can be null, you don't need to specify also. So this is going to be my output layer. So in between, how many hidden layer we are creating and what type of activation function we are going to use, that we are going to see. After doing that, what we will do, we will try to compile it, right, based on what loss method you are going to use and what optimizer you are going to use. Okay, then finally we will try to fit our training data into our model by giving the epochs count. Okay, so let us see one example based on this program. Just a minute. Okay, hope my screen is visible now. So the problem statement we have taken is house price prediction. So based on past house prices and parameters, we are trying to predict how much our uh, TensorFlow can able to predict our uh, house price. Okay, so for that we are going to import libraries. So what are all the libraries we are going to use is just TensorFlow, which is we needed, and then Panda and Matplotlib. Okay, okay. Then we have to import the data set. The data set which I have taken is sorry, kchouse.data.csv. Okay, so okay, so it is taking time to importing it. So we will go further. Okay, so let us wait this particular process complete. Then only we can able to check the head and other things. Okay. Usually it will not take this much time to complete. Just a minute, I will.
Sir,
Yes,
sir, do you have any template of all this, like import libraries, import dataset?
yes, I have sent you, I guess.
Okay, okay,
In one class, I have added the template as well, like given us template. One or two things only it's going to change. Okay, or else I will send you the template as well.
okay, sir.
Okay. In today's class, when I'm giving the data set, I will give the template as well. This will be
Okay.
easy for you as well. So just need
Yeah,
to fill the areas.
okay.
Okay, I don't know what is happening. I will restart it. Okay, sorry. Okay, so my data set has been taken. So now if I go and check my data set means dot head. So here if you see means we are having 21 columns. Okay, ID, date, price, everything is there. So in that, which is going to be our output column, the price is going to be our output column, and then the ID and date we are not going to use because that is not going to be useful in any ways, right? So price will be my output column, which is Y, and the remaining I'm going to take it as my X. So if I take remaining means I think 18 columns will come. Okay. So based on that, we are going to calculate. Mm, Then I'm splitting the X and Y. Okay. So if you want means you can drop the ID and date. Okay. So here X I'm taking it as. So I need all the rows and then from 3. Okay, because this is third column, right? 0, 1, 2, 3. So from third column to remaining all column, I'm going to pass it as my Y. Sorry, X. And then for Y, I will take only the uh, price column. Okay. Then what we have to do? So we have to do some data cleaning, or we can say like conversion we have to do, right? Because we each of them are in different format. So what we will do? We will do standardization or normalization, right? So here I'm going to use min-max scalar method. Okay, we have seen in PPT also, right? Mostly they use min-max method. We can also use standard method based on the problem. Okay, so here I will do with min-max scalar method. Okay, so scalar. So for that I'm just importing the sklearn pre-processing. Okay, min-max scalar, and then I'm initializing it. Then we will pass all the x values to transfer the data, right? So the new data I'm taking it as x scaled data or something. Okay, scaled means, so what we have to give? We have to give fit transform the data which we have collected in the x. Okay, so now we got the new data. Okay, x scale data. Okay, so everything has been converted into some uh, standard format. Okay, then what we will do? We will do some splitting, right, for the training and testing. So that is what I'm also going to do. Okay, here if you check info or something means, okay, we don't have any null values also. Okay, so we can directly start using it. If in case any null values are there, some differences in the numbers means, we have to go for that mean, median, like that we will do, right? Sorry, mean and mode, something you will do. So that process we have to do it. Okay, here no need to do anything. So I'm splitting the data. So this is also previously used the same code only. Just um, from model selection, we are going to import train test data. Okay, so here we have to pass the x scaled value and then the y, and then test size I'm taking like 0.25, anything you can take. Okay, and then what does we will give? We will give some random state, right? So I'm just giving it like 1. Okay, okay, did I give it? Okay, wait, I will run this here. Okay, okay, training and testing has been splitted properly. So now only we are going to go for what? The TensorFlow method, creating the neural network concept. Okay, so for that, what we can do is, so we can create a model from tf dot keras dot models dot sequential. Okay, either you can do directly like this, or if you want means you can import like from tf dot keras dot model import sequential, like that we can give, and then model equal to sequential. So both are same only. Okay, then what we have to do? We have to specify each layer, right? So in simple neural network, in that temperature based, I haven't given maximum parameters. Simple parameter only I have given. So here we are going to specify the activation function, and we are going to give more layers. Okay, there we didn't use any hidden layer, right? Only one layer was there. In that we pass the input and then we got the output. So here the first layer I'm going to create will be my input layer, correct? So input will be passed in that. So for that what we have to go, so just model dot add. Okay, so tf dot keras dot layers. Okay, dense, so it will create fully connected network. Okay, so inside that how many neurons you want. So in my case I'm just giving like so initially I'm giving 20. Okay, just random value like that I'm giving. Later on we will try to increase it and we will check how my output is coming. Okay, and then I will give the activation as ReLU method. Okay, mostly we will use the ReLU method, and for output either sigmoid or linear method we will be using. Okay, so I am specifying the input shape. So how many values I am going to pass. So input shape is equal to how many columns we have taken? 18 columns, right? So I will just specify it as 18. Okay, this number should be matching with the how many columns you are passing. Okay, otherwise it will throw some error. Okay, and then what we have to do? So another hidden layer I'm creating. Okay, same thing I'm going to give. Instead of input shape alone, I will not give. Okay, so remaining is going to be same. Okay, hope I have closed it properly. Okay, if you want, you can give another one layer also. Okay, I'm just giving another one layer also. Okay, then sorry, I have to give it as model dot add. Okay, otherwise I give like this. Okay, so now I have created two hidden layers. Okay, and then I'm creating my final output layer. Okay, so tf dot keras dot layers dot dense. So here how many units I am going to pass? Only one unit. Sorry. Okay, and then in the end I can specify like I want it in linear method. Okay, so final is going to be linear. First we will run this and check. Okay, so no error. So next step what we are going to do, we have to compile our model, correct? So compile dot sorry model dot compile, and then what optimizer we are going to use? So Adam optimizer I'm going to use. So I will specify it as Adam, and then for finding loss I will give it as mean square error. Okay, okay, so let us check whether it is okay. So simple change only. Up to splitting we are doing the same thing like how we did in machine learning. Only the algorithm part is going to be differ. So here I have taken like two hidden layer, output layer and input layer, and I am passing 18 inputs to my neural network, and then I am using a compile method. Inside that I am passing optimizer and loss. Okay, and then finally I have to do the fitting, correct? So for that, so I will create on epoch history. So model dot fit. Okay, x train value, y train. Sorry, y train, x train value, y train value. Along with that, I am have to specify the epochs count. Okay, epochs I am giving it as 10. Okay, initially I am giving 10. So here, if you want means you can specify additional values like batch size also. Okay, we have seen batch size, right? Based on the batch size, it will pass the value as a batch. Okay, here in our example, we are having a lot of rows. So we can pass the batch size also. Okay, so batch size, I'm giving it as 50. So 50 it will try to upload it into our model. And then one more thing also is there, it is called as validation split. Okay, why we go for this validation split is like in this training and testing set, what we will do, we will split 80 percentage, like here I have specified 25, so 75 percentage of the data will go for training and 25 will go for testing, right? Likewise, inside the epochs, when each time one iteration is completing, we will take some 10 or 20 percentage of data separately from the remaining, like yeah, 75% we have taken, right? From that we will take some 20 percentage of data separately. With the remaining data we will try to train our model. Okay, after completing each iteration, it will check with the separated the validation split data. Okay, whether it is predicting it at that point or not, so that when we are plotting a graph, we can able to identify how it was performing when we are training the data, and how it is performing when we are validating the data. With some new data only we are going to pass, right? So based on that, we can see whether validation time it is predicting properly or not. Okay, for that purpose we are giving validation split. Okay, so 20 percentage of data I'm going to give it for validation purpose. Okay, so this is will take some time, right? So we are having like heavy losses there, but how to identify like whether we can go for further change or not? By plotting it we can able to identify, right? So uh, initially I have given only 10 epochs and then 20 units. So for this, how output is coming, and then by changing whether we can able to increase our accuracy or not, we will see. Okay, so based on the training or this alone, we cannot able to a conclusion. That's why we go for the R2 score or mean square error. We will try to find, okay, whether our score is high or not. Okay, that is what we will also do in machine learning, right? For regression type model, we go for R2 score and mean square error, and for classification type problem, we will go for confusion matrix and then accuracy score, right? Similar thing only you're also going to do. Okay, so if I check epochs history dot history dot keys. So here we got two things. So loss is there, and then val loss means validation loss is there. Okay, based on that we will try to plot our graph. So for that, plot, so history. So I'm going to plot the loss value and then value loss. So title we can give it like model loss. So X label is going to be my epoch counts. Epoch number. So training and validation. Okay, loss. How much loss I got? And then since we are going to use, wait, we will run this and check. Okay. So here if you see means initially it was high, both the training and testing time it was high, and then it is slightly started dropping, and after some point of time it is like no any change in my training and testing, okay, validation time. Okay, so this is from this value we are getting like this. So we will check whether I can able to attain my accuracy or not. Okay, how much it has predicted correctly or not. So for that, we will go for the evaluation, right? Validating. We are validating our model. So for that, what we will do? So we can give like, so from metrics, I will import R2 score and then mean square error. Mean square error. Okay. So mean square, for mean square error, we will check with. Okay. Do we created any Y test or Y predictor? Yes, we have did right. Okay, we have not uh, predicted anything still now. Wait, let me check once. I've tried to fit it to my data. Okay. I guess somewhere we have missed something. We haven't predicted, right? Correct. So here I will predict it. Okay. So because we have just given the training and validation loss only we have test. We haven't predicted with the separate item. Correct. So for that I will do the prediction. So for that I have to pass the X test value. Okay, then only we can able to compare, right? So what is the Y predicted value and then Y actual value. Okay. So okay. So if I go and check Y predict means, so this is my predicted values. Okay, now I will try to compare and find the difference. So Y test and Y predict. Okay, so then what I have to do? Similarly, I will be finding for R2 score as well. Correct. So okay. So when we are seeing itself, we can say like only 0.28 only we can able to attain by giving this particular epoch value and then this hidden layer values. Okay, there is no any hardcore rule like this many hidden layers we have to do inside this many neurons we have to do give like that. There is no any specific rule is there. Okay, but if you see some basic logics, everything means our number of hidden layers should be less than, it can be maintained with less than the input values which you are passing. Okay, that we can take it into consideration. And when you are going for more than two hidden layers means it will increase the complexity of our program as well. Okay, so we can maintain with one or two hidden layers by changing the unit counts as and then the epochs counts. We can able to try to check our model. Okay, based on the outputs we are getting, whether it is giving some stability or not. After some point of time, if you have done the uh, conversion for uh, say, mean temperature conversion if you are done means even after giving some more value also you might have seen the graph might have not changed anything much. Okay, in that case we can say that okay, after some point of time there is no any further learning has been done in this particular model. Okay, so it will take some time to identify okay whether to stop this or we can further proceed with this. So here I am going to increase it and I am going to check whether I can able to achieve my at least it is very less value which is not something we accept. Okay, so we will go for a little bit change. So instead of giving it as 20, let me go for 50. Okay, so I'm changing everything into 50 and here epoch count I'm giving it as okay, again I will give it as 50. Okay, so I have told we should run it from here or else you can run from the beginning as well. Okay, it is not going to change anything. In sometimes if you are getting some error, okay, during this line only you will get error mostly when you are trying to run your code because of some older values which are already present. In that case, if you are getting some error that is the input data is not matching, the number of given is not matching, like we have changed here, right? Sometimes it will not match. In that case, we have to rerun just by giving this restart and run all these cells. It will rerun so that your error can be overcome. Okay. Okay. I have given 50 counts. So by seeing the loss also you can assume like whether it is reducing or still it is maintaining. See if you see means my loss is getting reduced. Initially it was high 98 something is there and then it is slowly reducing. Okay. See, I gave first 10, it was lost like this, and then for 20, it is getting reduced, 30, 40, 50, and all like more or less very less change only you can able to see both in the training as well as the validation. So for this, we will check what is my accuracy. See, I got 72. Okay, 0.72 means like we can say it as 72 percentage, right? So that much R2 score I can able to attain by simply changing those epochs count. Okay, I will do one more time whether I can able to increase the 72 to some other value or not. So for this what I can do is uh, okay, only I change epoch and then I will try. Okay, just I'm giving 100 counts, let us see how it is running. Okay, in case any improvement is not found mean we can go with the lower value also. Why? Because the more number of epochs you are giving, the time it will take to solve the problem will be high. Okay, it will take lot of time to complete this iteration. Okay, here it has taken 260 data, I mean 260 training set, right? So that's why it is doing like this. If in case you are going for image classification type of problem, in that case you are passing like 10,000, 20,000 like that higher values if you are passing means in that case for completing one iteration itself it will take lot of time. Okay, in that case if you are going for Google Colab and you are enabling the GPU means your time can be little bit saved. Okay. So see 77 percentage I got. Initially I got 72, right? So likewise by changing we can able to attain some certain point. Afterwards, even if you are changing anything also, you will not see any much difference. Like point difference will be there, or else that also you may not see. Sometimes it may be reduced also. Okay, so what you try? You try to make it as 80, like point 80 you can able to bring it or not. So during lab time you try. Okay, that will be useful for you. So this is a simple example for linear based problem, I mean sorry, regression based problem.